Hey everyone, today I'll be doing the term 1 week 11 mechanics past papers for the periodic. So these are the past papers that you need to know. Okay, there are 7, I'm pretty sure. 1, 2, 3, 4, 5, 6, 7. Yes, there's 7. So we'll get started with the first question. A block A of mass 80 kilograms is connected by a light inextensible rope. This is very important that they tell you this. Inextensible. Okay, this means what you get from this means that there's tension. Okay, because if it's extensible, then that's a different story. But because it's inextensible, you have tension. Now, a light inextensible rope to a block B of mass 40 kilograms. The rope joining the two blocks is taut and parallel to the line of greatest slope of a plane, which is inclined at an angle of 20 degrees to the horizontal. A force of magnitude 500 newtons is inclined at an angle of 15 degrees above the same line of greatest slope acts on A. The C diagram, okay, whatever. The blocks move up the plane and there is a resistance force of 15 newtons on B, but no resistance force on A. Okay, so let's start labeling our forces. So I'm going to start off with B, since it's the one that's, the closest. So you have the weight, which is like this. Okay, now this weight, we're going to call it mg. This weight has two components, right? Since it's on a horizontal plane, it's not exactly like this. You have the y component, okay, which on an inclined plane, by the way, normally the y component of the weight, normally it is w sine theta. However, when it's on an inclined plane, you can figure this out by trigonometry and doing vector addition. You'll find out that this is w cosine theta, or mg cosine theta. Let's keep everything in terms of mg, right? Now, you also have the x component of the weight, okay? Now, this one, since this one is cosine, you can tell that this one's going to be sine theta. So, mg sine theta, right? Now, we also have friction, right? They told me there's a resistance force of 50 newtons on B, which means, right, we have, it's not necessarily friction, then it's just a force. So, we're going to call this force let's say small r, resistance equals to 50 newtons. Okay, now we also have the normal, so we're gonna draw an arrow up like this. Okay, and we're gonna call this force N for the normal, right? Now, by the way, always make sure to put arrows whenever you have them. Here we also have tension between the string, okay, and this is pretty much all our forces on B. Okay, now let me just join this time to show that there is tension. Okay, for A, what we're gonna do the same exact thing. Let's resolve it into its components. So the y value, the y component of the weight is mg cosine theta, right? And then you have this here. You have mg sine theta. You have the normal. And here's what's interesting, right? What's nice about this is, okay, you have this force of 500 newtons. You can notice that it's at 15 degrees, right? It's not exactly whatever this is, right? So that means that there's also a y component of this force, the 500 newtons. Now, the y component of any force except weight when it's on an inclined plane, it's gonna be f sine theta. Okay, so here we're gonna write 500 sine 15 degrees, because that's what's given to me. Okay, and now we also have the x component, right? So I'm not even solving anything, I'm just resolving into its components. So this is here 500 cosine 15 degrees. All right, now this is all established. Now this is a much easier problem now that we have everything visualized and much simpler. Okay, now we start off with let's start off with B, okay, since B is the one down. So we're gonna write sigma, we're gonna do Newton's second law, F of xb. Since this block is moving upwards, right, you're gonna say it's equal to ma. All right, now what does this mean? This means that, let's resolve all of these forces. We have tension, we're taking the acceleration, since it's going upwards, we're taking acceleration this way. Always take the the positive sense of whatever you're drawing, because remember, you're gonna have positives and negatives. So for example, in our case, tension is positive, r and mg sine theta are negative, right? So we're always taking the positive in the direction of the acceleration. So we're gonna say tension, since it's positive, minus r, which is 15 newtons, so we're just gonna write 15, minus mg sine theta, so we're gonna straight away write m is 40, right? 40 g sine 20 degrees. This is going to equal to 48. Okay, now this has been established. Okay, perfect. So let's isolate tension, because we're going to need to find the acceleration of tension. We're going to use simultaneous equations. So we're going to say tension is equal to 40A plus 50 plus 40G sine 20 degrees. Okay, now we're gonna write this is equation 1. Okay, perfect. Now this is clear so far. Okay, we can use sigma Fy, but I don't find the need to, since it's only the normal and mg cosine theta. So I'm not gonna resolve it in the y direction. I'm gonna find now, let me change the color. I'm gonna find for the other force, for block A. So I'm gonna change it to black for this one. So sigma fx of A, so this is m, okay, is equal to m A, right? Now, so this is gonna show me that I can also resolve these components, right? Since they told me that it's applied on A, right? It acts on A, right? That's why if you're asking me the force, I'm talking about the force, this 500 Newton force. If you would ask me, okay, 500 newtons, isn't it like a system so we can apply it also on B? No, don't resolve it like that. Because they told you in the questions applied on A. So since we're taking the free body diagram separately, we're resolving in separate directions. Why are we doing that? So for A, we have, for the x-axis, we have 500 cosine 15 minus mg sine theta. So we're going to write 80g sine 20 degrees, okay, minus the tension, because look, oh, I forgot to draw it here. Yeah, so we also have tension here, right? Because again, it's between these two strings. So we're gonna write tension here. I forgot to resolve it. Okay, it's fine though, it's fine. So minus the tension T, because remember, we're using simultaneous equations in terms of the tension, is equal to MA. M is how much? M is 80. So 80A. Okay. Now, this has been established. Okay. We can rearrange to leave tension isolated. So tension is equal to 500 cosine 15 minus 80g sine 20 degrees minus 80A. All right, now this is equation 2. Okay, now I prefer personally, you can leave it in terms of G. It's fine, because in the end you can either factor them out or it will cancel out, so it doesn't matter, and you solve with it on the calculator. But I prefer to actually just solve for G. To take G in the past papers, they're all 10. So tension is equal to, for this one, for equation 1, 40A plus 50 plus 400 sine 20 degrees. Okay, this is now equation 1. Okay, now for this one, we're gonna do the same exact thing. Tension is equal to 500 cosine 15 degrees minus 800 sine 20 degrees minus 80A. This is equation 2. Okay, now perfect. So what we can do now, we have tension here, we have tension here. So what we're gonna do, we're gonna write substitute. I'm just write sub 1 into 2. Okay, now doing this, okay, that just means we have tension here, we have tension here, you're gonna equate them. So 500, or sorry, since we said 1 into 2, 40A plus 50 plus 400 sine 20 degrees equals to 500 cosine 15 degrees minus 800 sine 20 degrees minus 80a. Okay, now you notice here that we have a. We can take them on one side and leave them as a term, right? So we're gonna leave the a's on one side of the equation and everything that's numerical that we can find the value of on a calculator on the other side. So take 80a to the other side, you get 120a equals to, now you're gonna take the 50 and the 400 sine 20 degrees to the other side. So you're gonna get 500 cosine 15 degrees minus 800 sine 20 degrees. Okay, that's literally just this. We didn't write anything new so far. Okay, minus 50, that's what we took from the other side, minus 400 sine 20 degrees. All right, so now you're gonna divide all of this by 120. So you're gonna write 500 cosine 15 degrees, blah blah blah. So let's write it again really quickly. Minus 50 minus 400 sine 20 degrees all over, this whole thing is over 120. You'll get a to b on a calculator. So open bracket, 500 cosine 15 degrees minus, sorry, syntax error, what I pressed equal. Okay, 500 cosine 15 degrees minus 800 sine 20 degrees minus 50 minus 40 sine 20, close the bracket, over 120, gives you, how did I get this number? 1 second. This is not the right answer. Okay, no, my working was right. I just paused the video and I did it again. I think I just pressed the wrong button on my calculator. Anyway, I think, let me just make sure. Yeah, no, it is working. The working is correct. This part is correct, this part is correct. I put them all at once on the calculator and I think it gave me a wrong answer. But anyway, you solve for this part first. I solved for the numerator first after I paused the video. You get 22.5. 22.5. Right? Now divide 22.5 by 120. You'll get 0.187 or 1878 meters per second squared. You will round this to, because they tell you to give your answer to 3 significant figures, 0.188 meter per second squared. Alright, now this is the answer to the first part. My bad, the working was correct, I just don't know what I did wrong on the calculator. This is a correct equation, by the way. Like, let me do it on the calculator again. Maybe I just did something wrong the first time. Because when you solve for the numerator alone and then you divide it, you get the right answer. So 500 cosine 15 minus 800 sine 20 minus 50 minus 400 sine 20 over 120. Yeah, no, you do get the right answer. I don't know, I think I pressed something on my calculator the first time. Yeah, this is the correct equation. So now let's check this with the marking scheme. Oh wait, no, they want the tension also. They want the tension in the rope. Okay, for the tension, I'm gonna write in light blue, or I'm gonna write in green. Or was there green? I'll start writing green. I don't know. Don't write in green in the actual exam. Okay, now you have these equations, right? Look here. You have tension is equal to 40A plus 50 plus 400 sine 20 degrees. We have A, so we can write tension is equal, oh, this color is disgusting, never mind. Also, I'll write with purple, Tension is equal to, right, 40A plus 50 plus 400 sine 20 degrees. Alright, now you have A, so you're gonna substitute it in here. So this equals to 40 times 0.188. Okay, now on the actual exam, use the calculator value, right? Like write down 0.188 and use that in your written working. But in the calculator, you know how you have the answer button? Since you found the acceleration at the last thing, right? It'll save on your calculator as answer. So you're gonna do 40 times answer to get the exact value, which is gonna help you get the exact number. Plus 50 plus 400 sine 20 degrees. This will equal to, or sorry, let's, since we made this way too long, let's just write here, tension is equal to 40 times answer plus 50 plus 400 sine 20 degrees. 194.3, which is the correct answer. So tension is equal to 194.3 newtons. However, remember 2 significant figures, so you're going to round down to 194 newtons. This is the correct answer. Done. Okay. So let's compare it with the marking scheme. After every question, I will check with the marking scheme and I'll show you how they get marked. So let's pull out the red pen here. For the first mark, you need to attempt Newton's second law. Who is Rajan and why is he sending me a snap? Let me turn on Do Not Disturb. Okay. For the first mark, you need to attempt Newton's second law for at least one case. So they'll allow sign errors and they don't allow G missing. So you have to write G, or you have to write 10, whatever. It's fine. So correct number of times of the law. You just need to attempt Newton's second law and you attempt it correctly. So you should get T minus 40G sine 20 minus 50 equals 40A. Whatever. It's your working. Basically, it's your working. If you attempted Newton's second law, you get the mark. So خلاص, you get the first mark here. You get M1. This is M1 for the first mark. Okay. Now, any two equations will give you A1. Since we have 1, 2, A1. Okay. Now, for attempt to solve for T or A. We solved for A, so we get this. Or actually, let's put it up here because this is the actual mark. This is the solving. Okay, and then you get acceleration is equal to 0.188 meters per second squared, which is what we got, A1. Okay, and then tension is equal to 194 newtons. This is A1. Okay, so how many marks did we got here total? 1, 2, 3, 4, 5. So we got 5 out of 5 marks. All right, now moving on to part B. Find the time it takes to reach a speed of 1.2 meters per second from rest. Okay, now if you notice, here we have an acceleration, right? And obviously the acceleration is not changing if it's like this, if it's this system. So acceleration is constant. Acceleration is constant. What does that mean? It means we're moving at UARM, right? Now, for UARM, and you want velocity, right? You have a bunch of equations relating velocity. However, they all involve something you don't have. You don't have time, which is what you're trying to find, right? And also you don't have distance. So anything with distance is out, right? We're gonna want time as a variable left over. So anything with distance is out, right? So we can either use the time independent equation and then find time using another equation, or we can use the simplest thing. A is equal to V minus V0 over delta T. Now, again, we don't have distance. This is not provided, not given. So what can we do? We cannot use this, right? We're gonna use this. Okay, I don't know why I drew it like that. So we have acceleration. So to rearrange, you're gonna get time is equal to delta V over A, which is equal to, they said that was released from rest, I'm assuming. The rope joining two blocks, which is inclined 20 degrees, 20 degrees, with a slope. Okay, wait, was it given here? Yeah, from rest. They did say from rest. I need to read better. They do say from rest. So what does that mean? That means that V0 is equal to 0 meters per second, right? So remember, it's V final minus V initial over acceleration for the time, right? For the time. So what we're gonna do is now substitute in our values. Time is equal to V final is 1.2 meters per second. They gave it to us. They told us find the time that it takes to reach 1.2 meters per second minus 0 over acceleration, which we found to be 0.188. This equals to 1.2 over the answer, 6.39 seconds. And this is your final answer. Okay, now the marking for this is really simple since it's only 2 marks. You write that 1.2 is equal, okay, this is just a weird equation. For use of constant acceleration formula and solving with T for the positive A. So yeah, use of constant acceleration formula, this is the use, and we solved with T with the positive A, so this is correct. You get M1 for this. this and this. Okay, now for the second mark you get A1 for writing 6.39, and that gives you 2 marks. So this is the end of this question, and the total is 7 out of 7. Okay, now moving on. A block of mass 5 kilograms is placed on an angle or placed on a plane inclined at 30 degrees to the horizontal. All right, easy. The coefficient of friction between the block and the plane is mu. This letter is called mu. Okay, now this is figure 6.1. With a force, when a force of 40 newtons is applied to the block, acting up the plane parallel to a line of greatest slope, the block begins to slide up the plane. See figure 6.1. Okay. Show that mu is less than, this is less than 1 over 5 radical t. Now, it's very easy to show this, right? There's a reason it's only out of 4 marks. So, here, if you notice, we have the force here. It's not at an angle, right? It's only at the x-axis, right? So that's fine. Now, so that means we don't have to split this into its components, making our lives very easy. However, the weight is obviously acting like this. Now, if this was a flat plane like this, right? Remember your usual XY plane. So I don't know what's wrong with my pencil thing. You will see that we don't need to split it into its components. However, this is the X plane. This whole thing. I drew a sign, mashallah. Right? So it is at an angle. Now, which is exactly why, by the way, look, because technically the formula is still, like if we put this angle here, this is going to make a 90-degree triangle here. This makes 90 degrees, right? So what is this going to be? 90 minus 30 is 60. So this is 60 degrees, right? So this means that you can use this, and you can now say, because this is the angle that you have now, WY is equal to mg sine theta. Okay, this is just basic trigonometry. That's why in inclined planes, when you have this angle given, you're using cosine instead of sine for the y, because it's actually this angle that's technically given to you, but it's not really given. It has like the underlying meaning. So instead of sine, you're using cosine, right? So, but however, I'm not gonna get into explanation about this because you can always find this angle, right? It's preference. If you just love using the formula Fy is equal to F sine theta. If you just love using this, then find this angle here, because this will always make a right triangle. Find this angle here, and then you can use that formula. However, this angle is given, so I'm not going to write this down. Okay, instead, I'm going to stick with the 30 degrees. And I don't want you using that way I just explained, because it's annoying and you can sometimes get very confused. Because some people might think that the angle will add up to 100 and not 90. And that personally happened to me before. So, for the y-axis of the weight, for the y component, which is not this, it's this. Okay, it is mg cosine theta, right? Or mg cosine 30. Let's start labeling from now. M is what? 5g cosine 30 degrees. This here is 5g sine 30 degrees. Alright? Anyway, I prefer using 30 degrees because this is very easy. 5g sine 30 degrees is half. Anyway, alright? Now, you also have the weight. You have the normal, sorry. This is the normal. Alright? And then you have this x component of the force. It's only acting on x. So let's just extend it. Alright. Now, sigma, this question is basically the same concept. Sigma of x. I forgot. There's clearly friction, right? If they're telling me to find the coefficient of friction, there's friction. So we're gonna call the friction F. Alright, now sigma of x is equal to MA, right? So we're gonna write sigma of x is equal to MA. Perfect. Now we're gonna find sigma of x. So what is it? We have 40 newtons minus, where is it? Minus friction. Don't draw the arrow, sorry. Minus 5g sine 30. Alright, this is for the x-axis. Done? We're done here. Yeah, we are. So this is equal to, m is 5, right? So 5a. Now, what we can do here is we can write that, we can just rearrange this equation, really. It's without that but. So this is 50 sine 30. 50 sine 30 is 25, right? This is equal to 25. Now, 40 minus 25, do it on your calculator. 15. So 15 minus f is equal to 5a, right? That means that f, this implies that f is equal to 15 minus 5a. Now, we're not really going to use this. It's useless, but we're not really going to use it. We might use it for a later question, but, you know, we're trying to solve for as much things as we possibly can, just to make our lives much, much, much easier. So, remember the formula. F is equal to mu n. Okay? Now, knowing this formula now makes your life really easy, because you can find n, you can state, let me just show you the working, because it's going to get really confusing. So, now sigma fy to find n. Sigma fy is equal to 0, right? Because the object's not flying in the sky or moving up and down, whatever. It's just like stuck to the plane. So, n minus 5g cosine 30 degrees is equal to 0, right? This means that n is equal to 5g cosine 30 degrees, which is equal to 25 radical 3 newtons. All right, now this is actually very confusing, because how is n equal to 25 radical 3 n? This is newtons. Okay, just don't get confused by it. So now you can write that f is equal to mu n. So this is equal to 25 radical 3. Okay, now moving on. 25 radical 3 mu, sorry, 25 radical 3 mu. Okay, moving on. We can show now that since the block is moving upwards, right, the block is sliding up the plane, this force, this 40 newtons, has to be greater than the negative force, right? It has to be greater than the force of resistance. So 40 has to be greater than the force of resistance. Now, we can write this in easier terms. We can say 40 is greater than, what was that? You can say 40 is greater than f plus, what is it? 5g sine 30. Alright, now you can rearrange this because you already have f. Where did that go? 40 is greater than 25 radical 3 mu plus 5g sine 30 degrees. Now, I don't like this 5g sine 30 degrees. I'm going to say now that 40 is greater than 25 radical 3 mu plus 50 sine 30. 50 sine 30 is 25. Yeah, 25. So, now I can say 25 radical 3 mu is less than, I'm going to take away 25 from this. It's less than 15, right? I just took this to the other side. So now I can divide, right? I can say that mu is less than 15 over 25 radical 3. This leads to the conclusion that mu is less than, do this on your calculator, 15 over 25 radical 3, radical 3 over 5, which you can write as 1 over 5 radical 3. And this is the final answer. So let's mark this. Now, by the way, the marking scheme is really confusing for this. So just check whatever you can check, really. Okay. Now, they start marking, because my method, they give you two methods from the marking scheme. And I don't know, it's very weird. Like, they grade it in a weird way. So, yeah, we'll mark accordingly. So, R in our case, by the way, is N, because they take, instead of the normal reaction, we start it with normal, so it's N, but they take the reaction part, they take it as R. So whenever you see R in the past paper marking scheme, it just means the normal reaction, which is N. Now, R is equal to, or N is equal to 5g cosine 30, which is what we have. This is B1. Okay? Now, state that the net force of the plane is positive with 3 terms, which is what we did, right? We stated that the net force of the plane is positive because we did that this 40 is greater than f plus 5g sine 30, which is, again, 40 is greater than this, and 40 is the up one. It's like this direction. So it means that we stated it as positive. This is equal to m1. All right, now you can say friction is equal to mu times 5g cosine 30, which is what we did. Friction is equal to mu n. Remember, they accept 25 radical 3, it's fine. So you can say this one as m1. Okay. Now, then they conclude mu is less than 1 over 5 radical 3. So this is A1. So for this, you get 4 marks. Okay.